Okay, go ahead, settle down, take a seat, and we shall talk about, or start reviewing some concepts. And just so when you work through the practice final exam, I'll start listing off things that you can do to kind of help you along the way, right? So ideally, when you work through the practice final this week, try to do as much as you can all by yourself, okay? Some of you guys have tutors, and that's fine. But don't do the practice final with your tutor. Do the practice final by yourself. Star the parts where you got lost, okay? Star the parts where you are confused, okay? You know, I structure the questions in a way that the question should kind of guide you as to what the next step should be, okay? Maybe the first part will say, what are the hypotheses? That should tell you, oh, okay, my first thing that I've got to do is come up with a hypothesis. And then it'll ask you the next thing. So it kind of guides you along the way, but some of you will still get stuck, and some of you will be confused, and that's okay. If that happens, you know, put a star and say, I got stuck here. I don't know what to do next. Okay? At the bottom of most of the problems, or many of the problems, I say, look at this problem in the book, or this example in the book, for kind of some guidance or some ideas. You can do that. Okay? Ideally, you would sit down and you can work through and you can see where you know things and don't know things. Okay? But if you get stuck, go ahead and look at the book and see if you can figure that out. Do as much as you can. Okay? And then only at the end, after you work through everything, then meet up with your tutor and have your tutor go through the problem with you, okay? Don't do the problem with the tutor, okay? Because, and this is anybody who gets a tutor, when the tutor does the work for you, everything makes sense. When I do things on the board, everything makes sense. You feel like, oh yeah, that class was easy, I get it, okay? Or things like that. That's why in class I purposely do problems and I say, try this out, because when you have to do the problem yourself, then you're like, oh, maybe I don't actually know, okay? Because I know when I do things on the board, it's just like, oh, okay, or maybe it doesn't even make sense, you're just copying everything down, you're just in a mad rush to copy things down, and if you have a tutor, and everything makes sense, but then when it comes to test time, or quiz time, or whatever, and you're given a problem and you have to do it by yourself, that's when you realize, oh, maybe I actually have no idea what I'm supposed to do, okay? So this practice final is an opportunity for you to work through and figure out the gaps in your knowledge, where you can say, oh, I understand this, I don't understand this. If you're going to see a tutor, you can say, I know this part really well, but we need to focus on this. And you can ask your tutor to make up problems challenging you in those aspects here, okay? You know, and next week when we go over the practice final, we're going to talk about a lot of these things again, but next week we'll just spend a lot of time going through the actual answers to the practice final. So when you approach the practice final, okay, there's a bunch of questions that are related to chapters 8 and 9. And the very first thing that you've got to figure out is you got to figure out, am I dealing with one sample or two samples? Am I dealing with means or proportions? Okay, because that's going to shape everything else. And if you don't get that right, everything else about your problem is going to go wrong. Okay? So you must figure out, is it means or proportions? When are we dealing with means? Numeric variable, okay? Means, okay? This is how you know if you're dealing with means, okay? If you've got a numeric variable, you're dealing with means. If you see the word average, the average is, and there's some number, okay? most likely mean, okay? Or if you see the word the mean is, or sample mean, or anything like that, okay? It might say population mean, or sample mean, whatever, okay? If you see any of these things is, some number, these are indications that you've got a mean. If you see a standard deviation is some number also, okay? Okay, strongly, I don't want to say always, but standard deviation strongly implies mean, okay? But the number one way is if you can tell if it's a numeric variable or categorical variable. I know some of you still have trouble telling the difference between numeric and categorical variables, and it crushes my heart, but so that's okay. I'll just have to live with that. Okay. It's just like the other thing that crushes my heart is when people say, when this is the number 0.05 and people call this 0.5. This is not 0.5. Do not say this is not 0.5. Okay, when we say this, I die a little bit on the inside, alright? Don't say 0.5. It's 0.05 or 0.05 or 5%. Those are fine, but 0.5 is a half. That's 5%. Okay. Huh? I'm hurting. Right? I've got hurt feelings. All right. Okay, that's okay. No, it doesn't really hurt my feelings. I just feel like you guys are the futures of our country.
I can be a poet.
Okay. Anyway. Proportions. All right.
I'll be a poet.
All right. Proportions. We've got a categorical variable. All right. If you see the word proportion, all right, that's an indication that we've got proportions, or a percentage, usually, okay? Strongly implies proportion. The other thing is if there's a count, if it says we surveyed this many and this many, you're not going to see the word count, but the numbers are presented as counts. So it might say 360 out of 700 showed hair growth or something like that, right? That's a count. That's a proportion. So it might be like out of this number, out of blank people, some number had this trait, etc., etc. That's how we tell if we're dealing with means or proportions. Okay, and then the other key part is, do we have one sample or two? One sample or two samples? That should be consistent. It's okay. Cardinal numbers. One sample or two samples. Okay, so how do we know if we got one sample or two samples? Well, see how many ends can you identify? Read the problem. If you can only find one n, meaning the sample size, n again is your sample size, then that means you only have one sample. If you can identify two n's, two sample sizes, you've got two samples. Okay? And that's how we know. We got one sample or two samples. Yes?
So for means and proportions, you use mu for means and p for proportions in the hypothesis.
Yes. Yes. So we'll talk about all of this. Okay? So once you figure this out, then you're either dealing with one, okay, So you got 4 possibilities. One sample mean, or 2 sample mean. Or 1 sample proportion. Or 2 sample proportion. Okay, so you got to figure that out. Once you figure that out, that's going to guide the rest of your problem. Okay, but if you mess this part up, if you think it's 1 sample mean, but it's actually 1 sample proportions, everything's going to fall apart. Or if you think it's 2 samples, but it's only 1 sample, it's going to blow up in your face, okay? And the worst part is you have no idea, right? You have no idea what's going on. You're just like, my answers aren't coming out, and then you're going to raise your hand. Are you sure the correct answer is here? Yes, I'm sure the correct answer is on the test, okay? So, students ask me that every time we take a test. Are you sure the correct answer is here? Yes, I'm sure, okay? Alright, so once you figure that out, that's going to guide the rest of your problem, okay? And then you've got, the problem will state whether you're dealing with a hypothesis test or a confidence interval, okay? So you just read through the problem. I guess the problem also tells you whether you're dealing with proportions or means or 1 or 2 samples, but the problem will clearly state, do a hypothesis test or do a confidence interval, okay? So we will tackle the confidence intervals first, okay? Okay, so once you figure this out, then you can do a confidence interval, okay? And we do confidence intervals for 1 sample mean, 2 sample means, and 1 sample proportion. We don't do confidence intervals for 2 sample proportions. They exist, but they're not covered in the book, and they're not covered in our class, so don't be sad. Alright. All confidence intervals are in the form of, okay, we make confidence intervals for a parameter, okay? So, and all of them are in the form of, in the center, we put our estimate of the parameter. Okay. Then we do a plus or minus, then a critical value, times the standard error. Okay. This plus or minus thing only exists for confidence intervals. If you're doing a hypothesis test, you never use this plus or minus thing, okay? People get that mixed up, but confidence intervals is when you use the plus or minus. Hypothesis test, you'll never use that. All right, so let's, I'm going to do this for each of these things. Okay, so the first one, a confidence interval for P, okay, will look like P hat, this is our estimate of the parameter, plus or minus our critical value is a Z star, and our standard error is the square root of P hat times 1 minus P hat over N.
Isn't it T star?
No. For P, for proportions, we use Z, okay? And Z, those are those numbers that you need to have memorized or something, right? It's 1.645 if it's 90%, 1.96 if it's 95, 2. No. They're in your book. They're in the study guide. Still back there. Okay, confidence interval for P. Okay, so the Z stars, just, you can look those up in the book. They're also listed in the study guide that's posted online. Okay, it's like 1.28, 1.645, 1.96, and I think 2.58. But
This is review.
Oh,
or
this
80,
is
99.
from.
Huh?
This is review. Okay.
So this is a review, okay? You guys, it's probably already in your notes. All right, then we have a confidence interval for mu. So this is based off, this is what? One sample mean, right? One sample mean. All right, our estimate of the parameter mu is what? X bar plus or minus, critical value is T star times our standard error, which is S over the square root of n. Okay, so all that's changing are the letters, but it's still in the same form. Our estimate of that parameter plus or minus the critical value times the standard error. And then the last one is a confidence interval for what? mu1 minus mu2. Two sample mean. So what is our estimate for the parameter mu1 minus mu2? In the center we put what letter? An estimate of mu is, no, x bar 1 minus x bar 2, okay? So this goes in the center. Then we do plus or minus what? T star times our standard error, which is just this ugly thing, S1 squared over N1 plus S2 squared over N2. So in the center, we put the estimate of our parameter. Then we have the critical error. We have critical value times the standard error. Okay? When we multiply the critical value times the standard error, that's called the margin of error. Okay, so these numbers combine to form the margin of error. Okay, and that applies to all cases here, all three of these. Is this okay?
Mm-hmm.
All right, and then our conclusions are always, you know, I am blank percent confident that the parameter is either p, mu, or mu1 minus mu2. Is between, you know, the low and the high values. Okay, and then you might ask the question, do we have, you know, based on the interval, do we have evidence that something is different from something? Okay? So for these two, for the one samples, question, do we have evidence that, the parameter, whether that's p or mu, okay, depending on whether you're dealing with proportions or means, is different from some number. Okay, how do we answer that question? Yeah, so if that number is inside the interval, what do you say? If the number is inside the interval,
So we do not have evidence that it's not.
yeah, we say we do not have evidence that it's different. That the parameter is different. And on the other hand, if the number is not inside the interval, yeah. Do you have evidence that the parameter is different? Okay. This is all review. These things should already exist in your notes, but I'm just kind of putting this in this summarized format, I guess. Is this okay so far? Okay, so if my confidence interval for proportion ends up being between, I say I'm 90% confident that the proportion of smokers in the U.S. is between 18 and 28%. Okay, so my interval is 18 to 28%, and I say, do I have evidence that it's different from 27%? You would say 18 to 28%.
Oh, so we have evidence
So,
that it is.
and then, so do I say, do I have evidence that our proportion of smokers is different from 27%?
No. We do not have evidence.
Yeah, you could say no, okay, because 27% is inside the interval, so we do not have evidence that in this case, the parameter is the proportion of smokers is different from 27%. Okay? So you should always know what the parameter is referring to. Okay, on the other hand, confidence intervals for mu1 minus mu2. Okay? You'd say, I am blank % confident that, the mean of population 1 is between this and this, much more or less than the mean of population 2. But then if somebody asks, do we have evidence that, they don't say the parameter is different from some number, they would just say, do we have evidence of a difference in means? Or, yeah, do we have of a difference between means? You would say, if what is in the interval versus if what is not. So if you're dealing with two sample means confidence interval, you're looking for the number 0. If 0 is in your interval, if 0 is in the interval, no evidence of a difference. Okay? And on the other hand, if 0 is not in the interval, we do have evidence of a difference. Okay? This should all feel good, alright? It should all be like, oh yeah, I get that. That makes sense, etc., okay? So it's just a matter of taking all of this that you feel like you feel good about and just making sure that when you see a problem all by itself, you can say, oh, I'm dealing with proportions and I've got one sample, which means I got this. And I can figure out these numbers, and then you punch them in and you get your thing, and you get the thing out, okay? And then you make your conclusion appropriately, okay? But there's a process that goes through it. But it's not bad. You just got to figure out means or proportions. One sample or two. That's going to guide you on how to do the rest. Okay, and then let's talk about hypothesis tests then, okay? Maybe if you're taking notes, you can turn your paper sideways and we'll deal with all 4 of these scenarios here, okay? So we've got one sample proportion. And we'll do one sample mean. And 2 sample proportion. And 2 sample mean. Again, everything depends on you reading your problem correctly and at figuring out which scenario or situation you're dealing with, because that's going to guide everything else. That's why it's critical that you can identify numeric variable and categorical variable, because that will decide if you're dealing with means or proportions, etc., etc., etc. Okay, so in this, you're going to have to write down a hypothesis. And in all of these, we've got a null and an alternative. Null hypothesis and an alternative hypothesis. Okay, if it's one sample proportion, your null hypothesis is what? P equals some number here, okay? Just as a placeholder, I'm going to put in the number, I don't know, 36%, okay? You put in some number. This number always has to be between 0 and 1 because it's a proportion, okay? All right, so this is just a placeholder number. Okay, always between 0 and 1, okay, because we're dealing with a proportion. If you want to put in a number that's not between 0 and 1 there, you're doing something wrong, okay? Either you're dealing with means and you think you've got proportions, or you're using the wrong number, okay? If you're, I mean, you could put in, but also just because it's between 0 and 1 doesn't guarantee that you're doing it right. It's just, at least you know you're not doing something wrong, okay? Right off the bat. And then the alternative, okay, you're gonna use the exact same number, whatever that same number is, you're gonna, the same number goes there, and now you've got a not equal to, or greater than, or less than, depending on how the problem is written, right? It's going to say, do we have evidence that this is different, or greater than, or less than, or whatever, okay? If you're dealing with a mean, it's going to be mu is equal, and then now you put in whatever number you want, okay? Well, whatever's written in the problem. So maybe it's 18.7, who knows, okay? Whatever, again, this is a number, just a placeholder number, just comes from the problem. The alternative is that mu, whatever, is greater than 18.7, you know, or less than, or not equal to, depending on how the problem is written. Two sample proportions. We write P1 minus P2 equals 0. It's always going to put, always going to put 0 here. And then the alternative, P1 minus P2 doesn't equal 0, or is greater than, or is less than, okay? But you're always going to use 0 there. Okay, and over here, when we're dealing with means, mu1 minus mu2 equals 0 versus mu1 minus mu2 is what? Less than 0 or greater than 0 or not equal to 0. Okay, again, always 0 here. Okay, this should all be feeling pretty good. Alright, each of these, you're going to have to figure out a standard error. Okay? The standard error here is the square root of p times 1 minus p over n. Here, use the p in the null hypothesis. Do not use p hat. Okay? So here you would use 0.36. Okay, whatever your data says, that doesn't go in for your standard error here. Over here, your standard error is S over square root of that. The standard error over here p hat times 1 minus p hat times 1 over n1 plus 1 over n2, where p hat is total success divided by total observed. This is the standard error for that one. I'll slide this up.
For the second one, how do you find the p-value?
There's no p-value.
No p-value?
This one right here?
Yeah.
P hat, right? Total success over total observed. Are we okay? Slide this up. Keep going. We're almost done. Huh? Okay, so once you figure that out, then you figure out your test statistic. Okay, in this case, it's a z-score. And here you would put in p hat from your data minus p divided by the standard error. Okay? So p hat comes from the data. Maybe that involves a calculation. Over here, our test statistic is a t-score, and we do x bar minus the mean over our standard error. Okay, so in all of these, we're taking the observed value from our data minus whatever's written in our null hypothesis. Okay, so here I've got a z-score, and coming from my data, I do p1 minus p2 hat. This is my observed difference minus my null hypothesis of p1 minus p2, which is 0, divided by our standard error. And over here, my test statistic, or t-score, is going to be x bar 1 minus x bar 2, my observed difference, minus 0 over standard error. Okay? So they're all kind of parallel in form, right? Your observed value from the data minus whatever is written in the null hypothesis, the value, whether that's a proportion or a mean or a 0, divided by the standard error. Yes?
These are all called test statistics.
Yeah, these are all test statistics.
Okay.
And for proportions, it's always z, and for means, it's always t. Okay. And then, what do? You look this up in your table. So look up in the z table. And here we look up in our t table. Find our tail area and our p-value. Okay, so find your tail area first, then figure out your p-value. If it's a one-sided test, just leave as is for your p-value. If it's a two-sided test, meaning there's a not equal sign, you double it to get your p-value. Okay, so this applies all across. Tail area equals p-value. Two-sided test. Two-sided test means there's a not equal sign in the tail. 2 times our tail area is our that applies for all of those. And again, and this next part applies for all. I'm going to write over here because I'm running out of space. If your p-value is less than alpha, reject the null hypothesis, and you say we have evidence that the null hypothesis is false. Okay? This applies to all four. Okay? So at this point, I guess I can get rid of the line breaks, whatever. And if your p-value is greater than alpha, do not reject the null hypothesis. And we say we do not have evidence that the null hypothesis is false. Okay, how's that? Alright, so with this, you should be able to get through the whole practice final, okay? And I encourage you, well, part of your homework that is not going to be collected is to do the practice final. And please, I would say do as much as you can all by yourself so you know what you know and what you don't know. Then, next week, you can ask appropriate questions and things like that, okay? If you don't do the practice final, you're just hurting yourself, okay? Alright, we'll see you guys next week.